Alrighty.
Well, it's not under my control at this point. Motivational. Well, it's
Alrighty.
harder than doctor.
So before we get started, I just want to say that Dr. Roberts is going to be here on Thursday, doing a presentation about advanced in-body problems of some sort. I'm not sure exactly what he's going to be talking about. So anyway, if you guys could come, that would be great. So we can have some seats so he's not just talking at a screen or me. Anyway, so today I'm going to be talking about documentation, code documentation, Doxygen, using Doxygen. It's for like simple class assignments, this is completely unnecessary, but for longer projects or projects where you're going to be working with people, or for a project that you're going to be handing off to someone, this is very important. So anyway, let's go ahead and get started on this. All right, so first off, I'm going to talk about documentation. Question, why do we need to document stuff? Anything.
So other people can understand our gibberish.
So other people can understand our gibberish, exactly. Say you were to build a widget, a gear. How would you document said gear?
CAD drawings and stuff? Or?
CAD drawings. Okay. So you need to be able to tell the machinist how to make it. Okay. And then maybe some documentation on how to install it in wherever it's supposed to go. So that's pretty simple. So all engineering, you have to document it. And there's three main reasons. So someone can use it, so someone can change it, and so you can remember what you did when you get forced to look at it 3 years later. And so in physical context, this could be user manuals for the first one, so someone can actually use it. Machining drawings, so someone can change it. Assembly drawings, so someone can put it together. Blueprints, plans, anything like that. So here's an example of a drawing. You see he's got all this, he says this thing's got a name, a material, what it's supposed to be made out of. Dimensions, he's got a 3D picture, so you kind of get an overview idea of what it's supposed to look like in the end, and then all these little cutout things here. And it's actually kind of sad that, they've got all the technical notations. You can't see it because it's a bad picture, but, this D here. Well, actually, let's start with the left-hand side. If that's the base, then if you flip it on the right-hand side and cut a slice, that's what you get. And on the right-hand side, if we take that, flip that on its side, that's what we're looking at there. And so by doing so, you can document every single part of this so someone knows how to make it and what it's supposed to look like. But my dad is a structural engineer. And he just got hired at a company because he has experience doing documentation, doing drawings. And all of their young guns at this company have no idea how to make a good drawing. None. And so he's been trying to whip these boys into shape and teach them how to make good drawings.
Is he actually doing them by hand, or is he doing?
No, he does them with a CAD program. He doesn't have a drafting board.
Sure.
That's how he learned, though, was on a drafting board. And they had classes on what all the little symbols mean. And they don't do that anymore. But it's just something you're supposed to pick up. But anyway, that's what my dad's been hired for at his most recent job, is getting people to make good documentation. And that's how important it is. So here's a really old one I thought was kind of cool. This is like some sort of train. Here's an assembly drawing showing all the parts, 1 through 8 looks like, and how the exploded view and how they all fit together. So that's useful. Here's a user manual. So how to make a gingerbread house. Step 1, get yourself a kit. Step 2, eat the gumdrops and put everything on the table. Step 3, get angry. Step 4, put on a Christmas sweater and look proud of yourself. And then how to make an alien. Get yourself an alien egg, watch it hatch, let it eat you, and then die. That's how you make an alien. All right, but I think these are making fun of IKEA instructions. And IKEA instructions don't have any words; they just have these little pictures, and they actually do a good job with them. I've had to put together IKEA furniture before, and they're fairly readable, fairly understandable, and they do a good job with them. And I think that owes a lot to their success. So anyway, code. We're talking about code. Code is an engineered product, and so it also needs to be documented. So you need two kinds of documentation. Documentation of the API, so someone can actually use it. This could be the GUI or the function calls if you're writing a library. And then documentation of the internals, so we can remember what we did and so someone else can work on it. So the first, yes?
Question, what's API stand for?
Application Public Interface. So basically, how does someone not familiar with your project going to use it? So for instance, the API for PowerPoint is what you see right here. You have to have tutorials, user manuals, demonstration videos, anything you can think of to tell someone how you use this and what all these little buttons do. Also, it helps if you can make your API user-friendly and intuitive. So by putting all these little pictures here and these little words, shape, fill, quick styles, arrangements, this little scrolly bar, oh, I can see all my slides, and new slide, that one's fairly obvious, right? So for the second kind, so documenting the internals of the code, good variable and function names go a long way for code that is self-documenting. Unfortunately, that's never really enough because you also need to have an understanding of the algorithms and the maths. You need to understand the function interfaces and the relationships between the functions or classes and most importantly, the underlying assumptions. And so this is where Doxygen comes in. And Doxygen is a program which can handle both kinds of documentation. It is the de facto standard for C and C++ code documentation. What that means is C and C++ has not said you will document your code this way, but it's what everybody uses, so it's the de facto standard. It uses information contained in the code and especially in the comments to build a website or build a PDF which explains the code. It understands C, C++, Fortran, and lots of other things. It makes cool looking charts and graphs, and you can use it to display equations, which is really necessary in our work. And it's extremely customizable. So everything starts with the doxy file. So if you type doxygen-g, this generates a default doxy file. All right, and we're going to show you some of this. Okay. Let's just... Alrighty. I don't even know if I have Doxygen installed. I do. Okay. So you type -g and it makes a doxy file. And if we look at this doxy file, we'll see it's really big. 2,300 lines. And it's full of comments and then not comments, comments, not comments. And so each little comment block here is describing the next option. Okay, so that's the layout of the doxy file. And so let's see here. So some of the basics. project name, output directory. Okay, so let's go find these things. In fact, can we do this? Yes, we can. Okay, so project name, that one's fairly obvious. Name of your project. Output directory, this is where it's going to put the results of the generated documentation. Optimize for. All right, so you can set optimize for C, Java, Fortran, VHDL, depending on what language you're using. And so it'll change some settings for that. Its default is C++, which is why there's no optimize for C++. All right, another important one, input. All right, so if we read this, it says, the input tag is used to specify the files and or directories that contain the source files, the documented source files. So you can either input exactly these files, or you can input directories. Generally, it's better to input your directories. And so you just put it in here, say, you can even do relative, so path names, so you can do something like this. All right, and so it says all of my source files are going to be in source, the source directory. Alrighty, file patterns. So here is where you want it to look for .h files and .cxx files, and maybe we'll get to this later, docs files. Okay. If you don't do that, then it will use a default list of all of these things. Okay. Recursive right here, this one's really important because generally your project is going to have lots of subdirectories, so you can keep your code organized. And so by setting this to yes, it'll search through all the subdirectories for these file patterns here. Okay. So let's see here. All right, so then we come to the big one. All right, so generally what you want it to generate HTML. And what it does is it generates thousands of HTML files that form a single cohesive website. Okay, so that's generally what you want. That's what it was made for, and it looks the best. But there are other options. Don't bother. They use the word generate in a lot of these comments, don't they? Generate doc set. I don't even know what that is. There's the other big one is LaTeX. So it can actually output to LaTeX, and I'll output a make file, so you can go into the text folder and type make, and it will actually compile your documentation into a PDF. And I haven't played with that one too much. I found it to not be all that useful and a little confusing as to how it works. But so this one generally is set to yes, so I change it to no because I don't care to have that. I just want the website, and I just made everything capitals. So, and there's a lot of others. I think HTML and LaTeX are the only ones that are on by default. Use MathJax. So if you're going to be doing, oh, bother, have an extra slashy in there. All right, so if you're going to have formulas, it's generally a good idea to turn on MathJax. Because MathJax renders LaTeX formulas for your website. It's a separate website that you send it the formula, it sends back an image. and they look really nice in your websites. If you do the default LaTeX ones, it has to go through this process where it generates these crappy looking images that don't look as good. So generally a good idea to set that one to yes if you're going to have equations in your documentation. And enable pre-processing. I'm typing. So let's see here. Enable pre. There we go. All right, so this is on by default. You generally want it on. What it will do is actually run your C or C++ code through the preprocessor, the C preprocessor. So just so you know, it does that in case it gives you trouble. So that's the basics of the documentation. Now, Doxygen is also capable of documenting undocumented source code. If you find the extract all button here, and we turn this on, and then we look for have dot. It's in here somewhere. There it is. All right, what this is going to do, if we were to run this Doxy file on a project that we had not yet documented, it would read the source code, and it's smart enough to figure out what functions call what functions and everything. And it will actually generate documentation, and it will generate call graphs. And these call graphs are pretty cool looking. So let me show you an example of some of this documentation. So this was generated using Doxygen. This is the documentation for LAPACK. So let's look here. Linear solve, double. All right, so here's the documentation that was generated for this particular subroutine, Fortran subroutine. And here's some useful information and the parameters and what they all do. Authors. Last time it was modified. Here's what the file actually looks like. And we keep scrolling down. And then we come to the cool part. This is call graph. So this function here in the gray, oops. Yeah, we have these cool buttons here. Calls all of these other functions. Because you can see they all end up calling this Zerbla thing, whatever that is. But this...
That one's a dead end.
What?
Like, set. I would just call them and nothing happens.
Well, it depends on what it does. DLA set. So here we jumped now to the documentation of DLA set. It says initializes off diagonal elements and diagonal elements of a matrix. So it's, yeah.
Doesn't necessarily have to all go back to one.
The arrow is just if it supplies something to it, if it inputs something to it.
Exactly. So this function calls, for instance, this guy up here, DLA bad. This function calls DLA bad, and it does something for the whatever this one is. And then there is also a caller graph. So everything that calls this particular function. And so by using these built-in tools of Doxygen, you can get a sense of how a project is organized and what the relationships are between the functions. And you can do that without ever having to touch the code. You just run Doxygen on it and it does all this stuff for you. So that's really handy if you've got an old code that someone else wrote and you need to figure out what it does, how it works. It's a good place to start. All right, so now we come to how do we actually document our code.
But wouldn't they still have to provide descriptions? Like it'll show you the layout, but
it'll show you the layout, yeah, but that's all it does. Because Doxygen is not smart enough to be like, oh,
this is what this does.
you're solving a matrix. No, it doesn't. It's not that smart. All right, so how do we actually document our own code? So This is a useful one. Warn if undocumented. It will tell you, it will just pop out a warning as it's going along and say, hey, you haven't documented this thing, so you can see if you've missed anything. You can turn that on. Now, generally what Doxygen does is it looks for special comment blocks in your code. And these comment blocks typically come right before the thing that you are trying to document. So if you're documenting a class, you put this special comment block above the class. If you're trying to do a function, it goes above the function, etc. So in C and C++, a special comment block begins with a normal comment, /*, but then you can either put an exclamation point or a star after it. And then Doxygen will say, oh, that's a special comment block. I should look at that one. And then you don't have to. So here's an example here where we don't have the intermediate asterisks. Doxygen pulls those out. It's fairly standard from what I've seen to put those asterisks in. In fact, Vim will put them in automatically for you if you turn that setting on. But Doxygen deletes them, so you don't need to worry about that. And you put all your comments inside these special blocks. Now in C++, you can also do 3 slashes rather than 2 slashes for a comment.
Any difference with that?
Nope.
Besides different color.
Nope. It's just style. My personal preference is this form here. That's my personal preference. Or you can do a // exclamation point. So that's an option. And
I've always just done /*, I think my comments, then /* just, like I've never done with the exclamation mark. Like what's the importance of that? Or a second asterisk.
so, yeah. So the C or C++ language has comments. Okay. And by putting the exclamation point, you're telling Doxygen that this is an important comment that Doxygen should pay attention to. Okay. So you can mix Doxygen comments and normal comments all you want. Doxygen just ignores the normal ones. In Fortran, you do it by doing a exclamation point and then this little right arrows greater than sign. That's what it is. And then any following comments have to have 2 exclamation points. And that's a special Doxygen comment block in Fortran. And every language has their little quirks, but you can take a look at that. So another thing, every documented entity has a brief description and a detailed description. Of course, neither one of them is necessary. You could have one or the other. You could have none of them. You could have both of them. All right? But the brief description is used in some places, and the detailed description is used in other places. So there is a variable called javadoc autobrief, and that's because Java has its own documentation system. And so this is making it look like that. And so if you have it turned on, then you can do something like this. You could do this / here and make that line be the brief description. And then you have a second block here, and that's the detailed description. Or you could just do a single one like this, where the first line is the brief description, and then everything else is a detailed description. However, if it's turned off, there are no brief descriptions. And so if you want a brief description, you have to specify it with this special notation here, with this @brief. Now, it's important to note also that the @ sign is synonymous with a /. Okay, and some people prefer one notation over another, but they are exactly the same. So this is for if javadoc is on, this is for it's off. Now, if we're documenting a structure, okay, so This one is struct vec3, okay? I don't have a detailed description, just a brief description because it's very simple. This is a vector in 3D space, okay? I could be even more explicit and say Cartesian space. Whoa. Yeah, okay. And so as a shorthand, you can place the documentation after the members of the struct. So this is for the struct itself, and then this is documentation for each of the members of that struct. And it's also important to note, if you don't have this, then this documentation doesn't matter. In order to document the members of the struct or the class, you have to document the thing itself, okay? But you can place it after by using this special notation where you have the less than sign. What it's doing is it's saying this documentation is for this thing over here. Because by default, it's saying, by default, Doxygen takes it and places it on the next line. So if you didn't have that, we'd have the y coordinate being documented as the x coordinate, which would be bad. All right, so documenting functions. So here I have a dumb function called x2, and it takes in a value and squares it. Okay. So here I say he computes x squared, and this is a special little notation here for an inline equation. It mimics the LaTeX inline equation with the dollar sign here. It takes in a parameter x, and x is the value to be squared. And it returns x squared, and I just copied that. Whoops. Okay, and then a longer description would go after that, if necessary. And we'll take a look at what this ends up looking like later on. In fact, why don't we do that right now? We'll just take a look at it. Oops, wrong button. Alrighty, so I'm using Doxygen for my own project here. All right, and I've already generated the website. So index is the default main page. Oh, didn't work. Did it? We'll find out. Nope, didn't work. It popped it up on my computer in my lab. So if anyone wants to go over there and look at it, they can. So let's look here instead. So eigen is also documented using Doxygen, and it's very well done. But let's say we wanted to look at the documentation for the matrix class. And it pulls up the matrix class here. And you say, see here it says this is the detailed description. Obviously you don't have a brief description for this one maybe. It is the workhorse for all dense. And then it has this little note here. It takes us to a definition of dense versus sparse. So that's kind of cool. Within eigen, tells us what the first three template parameters are. Okay, and if we keep scrolling down, it's going to take us to public types that are in the matrix class. And then it lists off all the public member functions here. So this, and they look like it's listed them all in alphabetical order. But if we wanted to know what count does, it takes us directly to the definition, to the documentation for the count function. It even gives us some C alsos, which is kind of cool. So they have an at returns in there, and it returns the number of coefficients which evaluate to true. So this is kind of what that function documentation ends up looking like. You get this nice little header bar. It tells us, hey, look, it's got an inline tag over here. And it's referenced by, so it tells us what functions call this one, and so on. Alrighty, let's look. All right, so you can, there's a huge list of these things, and so I can only give you a few, but at A displays the next word in italics, at B does one in bold, note makes a special note, which will be highlighted, bug documents a known bug and adds it to the bug list. Doxygen will put together a page of all the bugs. Same thing for a to-do item. It will make a to-do list. Cite, you can have a bibtext file and add citations from it. You can make hyperlinks and so on. Doxygen also supports the markdown syntax. So if you want something to be in italics, you surround it with underscores. If you want it to be in bold, you surround it in asterisks. You make a level 1 header, level 2 header. You can make lists. And those are pretty simple. Let's see, let's just add a little text box here. Hey, that is not at all what I want. Text box. API here, huh? So if you wanted to make a list, you just do a little dashy here. Even PowerPoint recognizes that. So that would make a list. If you do lots of these things in a row, it'll put in a horizontal line in the final web page. If you want code to be put in, you can use backticks, which is in the upper left corner of your keyboard. You can make hyperlinks with this syntax. You can show images with this syntax. You can make a fenced code block, and what that looks like is like this. So you put in lots of little tildes, and then you tell it what language you want, and then you can type away. Of course, PowerPoint's trying to be helpful in capitalizing things. Okay, and that makes a fenced code block. And this will actually show up. It'll be syntax highlighted. It'll be awesome. Or you can use entire markdown files as pages. All right, so all of what we've been talking about is documenting the internals. Okay, it hasn't really been documenting what it's actually doing. And so you can put that in by making pages. And so there's a special command called main page. And so what this is the first page of the website, that index.html I tried to pull up. It didn't come up. That would be the main page. And what this says is that everything in here now is going to be part of the main page. And you can make a hierarchy of pages. And so we say we're going to have a sub-page of the main page called intro, another one called advanced. All right, and so here we can, then in a separate file or in a separate block, we make our page. We say at page, intro, and we call it introduction. And then we say, here's the introduction. There's sectioning commands as well, so you can make a section, and those show up nicely. And this one has a tag called get start. So you notice this has a tag, and we use that tag here. Okay, and so it'll link everything together using those tags. After that, we put it the name of the section. We can make another page and use its tag called advanced and give it a title, advanced features. And then we can actually reference everything else before reading that was weird. We can reference the other pages using the ref command. And so we reference the intro and it will make a hyperlink so we can actually click on it and it'll take us there, which is really cool. Last but not least, this is a little more advanced, but you can have groups. So you can place documented items together into their own groups. Each group gets its own page, and this can be useful for placing the related items together. So you define a group with this command, and that just you can only have one of those, but you have it somewhere in your documentation, and everywhere else in the documentation you just mark it as being in the group. This item, this function, this variable, this namespace is in this group. So as an example, this is what I want. So I want to look at this. This is a .docs file, and this is just for a page. You'll notice if I open this up in gedit here, it's really kind of boring. So this is the main page. It doesn't have a title. This is the API documentation for Eigen 3. You can, this is an HTML link here, as a TGZ archive for offline reading. Okay, and they have a lot of other stuff. You'll notice that they have subpage commands in here. They have bold commands in here, an emphasis command. But it's fairly readable. It's straightforward to read. Now, if we open this up in Vim, I want to show you this. This is why Vim is awesome. Okay. We open this up in Vim. It looks the same. Nothing much has changed. But if we change the syntax to be C++ syntax, it recognizes it as Doxygen. And it highlights everything all nicely for us. And so this is really cool. Now, in order to do that, there's a couple settings you have to set up. So the big one is this, load Doxygen syntax. And then since I'm not using JavaDoc in my own documentation, I turn that off. And if you do that, then it will recognize, and it lost its syntax highlighting. It recognizes, so /B makes it bold, and so it makes the words nice and bold. The links show up in yellow. The HTML shows up in its different colors, and the link actually sort of looks like a link. The emphasis here shows up highlighted. It's pretty cool. Now let me show you what this looks like after Doxygen has been processed this. Go away. We click on the overview page right here, and this is what it ends up looking like. Okay, it has all these references. Here's those links we saw. Here's the download archive link. And now they're really fancy. Mine doesn't look like this. The defaults for Doxygen are passable, but they've made it really, really fancy, just so you know. But then they have the getting started page. You see they have code in here. And so if we were to look at their getting started, let's see here. There's a quick start guide. Is that what we want? Actually, let's just do this. Oh, really? Fine, whatever. We need a -r in here. My bad. No, it doesn't exist. I don't know where it is.
It's definitely capitalized, right?
Maybe, may not be.
Sorry.
Let's open up the quick start guide. There we go. So now that looks nice. I have a example program. So apparently there's an include command that you can use. Code /end code. So there's some interesting ones there. Some examples. Explanation of the first program. How to do the first program. You can put in tables. You can. Here's an equation that they put in here. And so this all ends up turning, yeah, this is it. A simple first program. Explanation of the first program. Here's their table. Here's their equation that they had. All right, so this is what Doxygen can do for you. Anyway, we're going to go ahead and close up, and I hope that's helpful. It may not, maybe, but in the engineering world, I will say this: documentation is critical. It sucks; no one wants to do it, but it has to be done. So make sure you do it and you do it right. And that's all I got for you today. So we'll talk to you later.